By now you should be familiar with the use of the distance formula and how to calculate the distance between any 2 points in the coordinate plane. What we're going to do now is we're going to use that formula in order to be able to calculate side lengths of a geometric figure and then use those lengths in order to be able to calculate area and perimeter. Our lesson question is how can you find specific properties of geometric figures in the coordinate plane? So let's get to the next part. Let's calculate the perimeter of a figure in the coordinate plane. Now we can find the perimeter, specifically of this quadrilateral DEFG, by finding the lengths of all the sides and then add them up. And I see that DE is horizontal, which means I can just count, going by twos because of the scale, 2, 4, 6, 8, 10, 12. I see that DE is 12 units. The others, however, I'm going to go ahead and have to use the distance formula. So let's start with EF. All right, well, this is going to be the square root of 8 minus 6 quantity squared plus 2 minus 6 quantity squared. Using F as my second point, E is my first point. So 8 minus 6, well, that gives me 2. Squaring that value gives me 4. And 2 minus 6 is a negative 4. If I square that, I get a positive 16. So I see this becomes the square root of 20. Well, the square root of 20 can actually be reduced as 2 square root of 5. You could figure that out using prime factorization. So let's move on to FG. All right, well, for FG, then I'm just going to make F my second point, G my first point. And I will get 8 minus 0 quantity squared plus 2 minus a negative 2 quantity squared. Well, 8 minus 0 is 8, and so when I square it, I get 64. And if I take 2 minus a negative 2, I'm going to get 4. Squaring that value gets 16. So I see I get the square root of 80. And that also reduces, this time to 4 square root of 5. All right, so we have 3 of our lengths in units. Now we need to move on to the last one, DG. All right, I'm going to take D as my second point, G as my first point, so I'm going to get the quantity negative 6 minus 0, quantity squared, plus 6 minus negative 2, quantity squared. Negative 6 minus 0 is a negative 6, and when I square it, I get 36. And 6 minus negative 2 is 8. Squaring that value gives me 64. Well, here, 64 plus 36, 64 plus 36 gives me 100. So I have 100 under the square root, and the square root of 100 is 10. So using these 4 lengths in units, I can add them together, and I'm going to find that I get 22 plus 6 square root of 5. That's the exact length of the perimeter, but if I wanted to simplify that, or not simplify, approximate it, I get to plug these values into a calculator and get approximately 35 and 4/10 units. Keep in mind that if you chose to put this into a calculator, putting in 2 square root of 5 is the same as square root of 20. So when you're using a calculator to approximate, it's not necessary to actually simplify the radicals. I just did that so I could show what an exact value would be as well. All right, so use this idea and see if you can find the side lengths on this next quadrilateral. Let's calculate the area of a figure in the coordinate plane. For this example, I'm dealing with a right triangle given A, B, and C vertices at -2, +5 for A, -4, -1 for B, and C at 1, 4. So we can actually draw these in and see our triangle. And it tells us that the hypotenuse is BC. And that makes sense because that shows us the right angle at angle A. We want to find the area. And the area of a triangle is equivalent to 1/2 base times height. All right, so that means I need to identify the base, which is going to be AC, and the height, which is going to be AB. So let's start with AC. Well, using my distance formula, I'm going to let A be x1, y1, and C be x2, y2. And plug in our values. So we've got 1 minus a -2, that quantity being squared, plus 4 minus 5, that quantity being squared. Well, 1 minus a -2 is 3. Squaring that value, I get 9. And 4 minus 5 is a -1. So when I square that, I get a +1. This gives me the square root of 10 units. All right, let's move on to AB. Same idea. Only for this example, let's go ahead and I'll just keep x1, y1 as A, and we'll do x2, y2 for B. All right, so that's going to be a -4 minus a -2 quantity squared plus a -1 minus 5 quantity squared. Well, -4 minus a -2 is a -4 plus 2, which is a -2. And if I square that, I'm going to get a +4. -1 minus 5 is a -6, and so when I square it, I get a +36, and what I'm left with is the square root of 40. Now, square root of 40 can be reduced down to 2 square root of 10, so when I want to find this area, I now have all the pieces I need. 1/2 times the base, which we found is the square root of 10, times the height, which we found is 2 times the square root of 10. All right, well, 1/2 of 2 is just 1. So I'm left with just the square root of 10 times the square root of 10, which gives me the square root of 100, or just 10. Since we're talking about area, we know it's in square units, and therefore the area of this shape is 10 square units. All right, I think you're ready to try another one on your own. In this lesson, we're working to answer the question, how can you find specific properties of geometric figures in the coordinate plane? And we've worked with the distance formula in order to be able to calculate side lengths. That allowed us to identify perimeter. Well, in this next part, we're going to be working with the distance formula again, but along with the slope formula, and that's going to help us verify some geometric properties. Let's see if we can determine if a point lies on a circle. Now, you might be familiar with the fact that a circle is defined by a set of all points in a plane that is equidistant from a center point. And in this case, they actually tell us that the center of our circle is actually located at the origin, 0, 0. They're also telling us that the point 4, 0 lies on the circle. So based on here, if I drew a radius from the center of my circle to that point, 4, 0, I could see that the radius is 4 units long. Because it's just a horizontal distance, I just counted that up. So radius equals 4 units. All right, well, the question is, does 2 square root of 12 also lie on the circle? Well, here we can use the distance formula. If I find the distance between 2 square root of 12 and 0, 0, well, then we can determine if it's 4, then yes, it lies on the circle. That length is not 4, either greater than or less than, we know it would not lie on the circle. So let's do that. So the distance, all right, well, I'm going to let 2 square root of 12 be my second point, and I'm going to let 0, 0, the origin, be my first point. So we're going to get 2 minus 0, quantity squared, plus the square root of 12, there we go, minus 0, that quantity squared. Well, 2 minus 0 is 2, and if I square it, I'm going to get 4. Square root of 12 minus 0 is square root of 12, and when I square that, I just get 12. Well, 4 plus 12 is 16, so I end up with 16 under the radical, and the square root of 16 is 4. Because the distance between 2 square root of 12 and 0, 0 is 4 units, and the radius of this circle is 4 units, then does 2 comma square root of 12 lie in the circle? Yes. Yes, it does. See if you can do this next problem on your own. Let's talk about the slope of a line. Now, the formula for the slope or the steepness of a line is given by the change in y values over the change in x values, where x1, y1, and x2, y2 are points on the line in the coordinate plane. Now, knowing the slopes are very helpful because parallel lines have the same slope and perpendicular lines have opposite reciprocal slopes, whereas the numerator and denominator are switched and one's positive and one's negative. We can use the slope to help verify a triangle is a right triangle because a right triangle contains two perpendicular sides where the right angle goes. Now this triangle has vertices at 0, 10, 6, 6, and negative 2, 6. And if I draw this triangle in place, it appears that I would have a right angle at angle E. But in order to verify that, I need to see what the slope of line DE is and the slope of EF and see if they're perpendicular. So let's start with the slope of DE. Well, allowing D to be my first point, E to be my second point, I'm going to get 6 minus 10 over 6 minus 0. It gives me a negative 4 over 6, which reduces down to a negative 2/3. So let's go ahead and find the slope now of EF. This time I'll let E be my, let's let E be my second point and F be my first point. All right, so that's going to be 6 minus a negative 6 up top, and 6 minus a negative 2 in the denominator. 6 minus a negative 6 is 12, and 6 minus a negative 2 is 8. And this reduces down to a positive 3/2. Notice that both of my slopes, my slopes are rather reciprocals of each other. The numerator and denominator have been switched. The top one is negative and the bottom one is positive. As a result, yes, we have verified these two lines are perpendicular, and as a result, triangle DEF is in fact a right triangle. So see if you can now verify if a triangle is a right triangle. Let's review the properties of quadrilaterals. Now, a parallelogram, it's a quadrilateral that has opposite sides parallel to each other. In addition to that, we can also say that opposite sides are congruent to each other. Now, if all the sides happen to be congruent, they're all equal to each other, you have a rhombus. But if instead you just say it's a parallelogram and you have 4 right angles, well, then you got yourself a rectangle. If you take the shape of a rectangle and a rhombus, and combine those properties together, what you end up with is a square, a parallelogram in which all the sides are equal to each other and you have 4 right angles. Now, although a square is a rectangle, a rhombus, and a parallelogram, a rectangle and a rhombus may not necessarily be a square. It has to make sure it has to have all the properties specific to that shape. I want to go ahead and take those properties and determine the name of this quadrilateral, the most specific name I can get. So I'm going to start off with the generic. Can I name it a parallelogram just to start? So let's find the slopes of these opposite lines, because if the slopes are the same, the lines are parallel. All right, well, the slope of KL, I'm going to get 5 minus 1 over 0 minus 3 using my slope formula correctly. And I'm going to get 4 over negative 3, or negative 4/3. What about the slope of JM? Well, all right, that's going to end up being a negative 3 minus 1 over a negative 1 minus a negative 4. And what that gives me is a negative 4 over a positive 3. And I see that my two slopes here are the same. But we need to go ahead and look at the next set of lines, next pair. Okay, well, doing that, I'm going to go ahead and take a look at the slope of LM. And so I'm going to take a negative 3 minus 1 over a negative 1 minus 3. Once again, make sure you use that slope formula correctly. I'm going to get a negative 4 over a negative 4. Well, that equals a positive 1. What about the slope of JK? Okay, well, that's going to be 5 minus 1 over 0 minus a negative 4. Remember, slope's just the change in y over the change in x. And I'm going to end up with a positive 4 over a positive 4, and yep, I get another slope of 1. So I've verified that this is in fact a parallelogram because I have opposite sides that are parallel. All right, well, if opposite sides are parallel, do I have a rectangle or a square maybe? Well, if you look at your slopes, no. None of my slopes are opposite reciprocals of each other. And since I don't have perpendicular lines, that means I don't have right angles. But I can determine maybe if it's a rhombus. I would have to just check to see if I have 4 sides that are all congruent to each other. Now, because it's a parallelogram, I already know that opposite sides are congruent. So let's go ahead and check KL and JK. If those sides are the same length, I will have in fact determined, then yes, it is a rhombus. So my values have already been plugged into my distance formula. Let's just simplify. 0 minus a negative 4 is a positive 4. And when I square it, I get a positive 16. If I take 5 minus 1 and I square it, I'm going to get 4 squared, which is 16. So I get the square root of 32. Now I can simplify this, but I'm just going to leave it just like this because I want to just compare it as is to the next one. I might be able to get an answer right off the bat. Let's look at the next one, KL. Well, 3 minus 0 is 3, and when I square 3, I'm going to get a positive 9. 1 minus 5 is a negative 4, and when I square that value, I get a positive 16. Well, 9 plus 16 is only 25, not 32. So clearly we can see that the square root of 32 is a larger value. Well, because this value is not the same length as this value, or JK is larger than KL, I can't say that this is a rhombus because I would have to have all 4 sides be the same. So the most specific name that I can give this quadrilateral JKLM is a parallelogram. Now see if you can use the properties of quadrilaterals to help you on this next example.